And good morning to all my super friends and happy, what is it? Summer solstice? Saturnalia? I know there's some event that's about to happen. Can't quite remember what. There's, something that happens around this time of year. Whatever that event is. I hope you have a great one. And Peter is already calling for lunchtime. Okay, before I say hello to everybody, I acknowledge the traditional owners of this land, the Wajungungar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So good morning. Yeah, Michael says, happy Festivus. It is the festival season. Simon became a silver sponsor. Thank you, Simon. I really appreciate that. So good morning to Chip, who was here at 8:58 yesterday, which I think was probably minutes after I queued the stream. To Simon, Stephen W. Peter was here this morning, might be back again. Michael, and just scrolling down. Who do we have in the chat? Mad Techie is here. Emmy is here. Steve the Squirrel apparently is here. David, Russell, Johnny Bergdahl. Good local time, ladies, gentlemen, and undecided. Yes. Who else? Sharky, good morning. So and Johnny says, you mean the Midwinterblot, the traditional Viking midwinter sacrifice. Yeah, that's the one. Happy Midwinterblot. Alistair, Gavin, thank you both for coming. Where am I? Okay. Okay, so you might have noticed at my ears, because in recent times I've been getting so many scurrilous accusations of committing squirrelcide, and so I thought that to prove that Steve and Steph are still with us, I would display their stuffed bodies mounted on stands on my chair. See, that just proves that I haven't done anything bad to them. Austin, thank you for coming. And Michael says, happy not working for 18 days day. 18 days, yeah. Well, not properly mounted, Chip. They are kind of precariously mounted. I would not be surprised if one or both of them takes a dive off the chair at some time in the next couple of hours. Chip and Immy, you both had the spicy cough not long ago. Are you feeling better? Are you both up 100%? I hope you've recovered. I really do. All gone. That's good. Oh my God, he killed Steve. Yes. Oh, what's that? Alistair said, can't live chat via YouTube on Tesla, so I count as 2 viewers. So you're... All right, I am beaming live into the back of Mr. Big's limo. How did it go? Off the relay tower, up to the satellite, back down. I can't remember the quote. It's been so long since I've watched Wayne's World. Denied. Oh, it was spicy. Okay, still tired, but getting there. Yeah. I had a nana nap yesterday. I'm still so tired. It's just really snuck up on me to riff off what Michael just said. Or sneakers. Yes, that's right. There was another quote in Sneakers about bouncing the signal off a satellite or something. Yeah, so after striking yesterday, I went home and showered, and then I just sort of thought, I'll lie down and just rest for a little bit before I get back down to the factory, and I ended up snoozing for like 3 hours. Okay, Squirrel Protection Society is here. Welcome, Squirrel Protection Society. I will be on my best behavior.
Imogen Ann said it was spicy, Jono. Still tired, but getting there, smile.
Yeah, getting there. That's good. That's good. I hope you get lots of rest. Now, what are we going to do today? What are we going to do? I had an idea, and it's probably a really, really bad idea because it was my idea. But we can see if it works out. What I was going to do was mess around a little bit with this firmware.
Creation said IOTAP.
Oh, IOTAP. I hadn't even thought of that. No, I was thinking of messing around with firmware to go into these little doovalakis right here, and maybe screw around with a bit of CAN bus stuff. And not necessarily getting it to running on the boards today, but I haven't done anything on this firmware since the last stream where we were playing around with it, and I thought that it could be interesting to talk through different ways of doing this and write a bit of code. Yes, Stephen, exactly right. The same thing we do every day, Pinky, try to take over the world. And what I've got here is the two relevant bits of firmware open, the PCB conveyor and the OpenKO firmware. And they both work independently in isolation. So I've got this conveyor belt firmware that runs on the ESP32S3 that is in this. So that firmware works to the extent that if I connect USB, where's the socket? Wherever it is, wherever the USB socket is. There. If I plug in USB, I can talk to it using G-code, and I can send a command like G28 to do the homing sequence, or G0. So G0 is like a G's go, is the way I think of it. So
Mitchell R said, "I'm thinking about how uncanny this is."
Uncanny. Yeah, so G0 is like a high-speed move, I think. And Y distance, so that's to move the back rail of the conveyor belt, so it adjusts the width of the conveyor. So I can tell it to go to a certain distance by sending it G0Y24, for example, would take it to 24 millimeters. And I've got M codes in here, M03, 4, 5, for running left to right, running right to left, and stop. So those are the basic things necessary to make the conveyor work. And this does work, well, it did work on my previous prototype. So not this one that is sitting right here. This is like the PCB implementation of it. Or maybe that code is on this, I can't remember. It's 2 years since I had this all plugged in and running. But to the best of my knowledge, this is the firmware that I was running on it at that time. And so you can set the speed and that sort of thing. Now there's no provision in here for the sensors, like an entrance sensor, an exit sensor, or anything else. And it is, I think this version was before, yeah, to do. Select pins for H bridge, ready in, ready out. I've already, yeah, I think I've done that in hardware, but I haven't done it in firmware. And I did the, where are we? Arduino, oh, okay, this is the graphics stuff, so I can display stuff on the touchscreen. What else are we doing? PWMing the backlight.
Mola said, "Badum tish."
Hey Siri, play a rimshot sound. All right. What am I doing? Okay, so this was driving a DC motor, I believe. Oh no, Y-axis stepper. Okay, so a stepper on the Y-axis. All right, this is starting to come back to me. I've got that 5-volt stepper on the Y-axis to move the back rail, and then there's a DC motor that just moves the X-axis. So X is left to right, Y-axis is front to back. So I'm using Y-axis to adjust the width of the conveyor, and X-axis to move the conveyor along, to keep it moving. Now where did I have this working? Let's see, motors, home Y-axis, set requested speed, set conveyor motor speed, stop. left, right. Okay, so this is using PWM, using the LEDC function in ESP32, because that's how you do PWM in ESP32. Motor speed, yeah, this was just with the DC motor. This was before, this is with the current hardware prototype without a stepper on the y-axis. Now, there was a comment, I noticed there was a comment on the last live stream from someone who suggested, and I apologize unless I go into YouTube and find this comment, I don't know who to give credit to, but someone said, had I thought about using an encoder on the DC motor? So instead of switching the DC motor to a stepper motor, I could just keep the DC motor and add an encoder to it. And, you know, the thought never even crossed my mind. I don't know if that is the best or a good approach. It probably is a pretty decent approach. Yeah, but it's one of the obvious things, and it just never even occurred to me. I think probably because I hadn't really thought about getting something like a small DC motor with a built-in encoder, and so in my head I was just thinking it would be easier to go to a stepper motor and use a stepper driver. But doing an encoder on a DC motor is probably a pretty good idea. So where else are we? G-code. Okay, so this is on the conveyor side. So we've got G-code. These are the different G-codes that it understands. And way back at the start here, I was talking about, you know, this is just in the comments. G28 for homing, G0, blah, Y, distance. So in here, this is where it defines it. So a G-code 0 is a move. G-code value of 28, like a G28, is a home. An M-code 3, spindle right, spindle left, spindle stop. And that is because I am misusing the spindle command to move this at different speeds in different directions. I probably could be using, yeah, well, conceptually, the thing is that if you send, that's right, I'm remembering my logic now. Now you might think that I should use a G0 command with a speed value on the x-axis to move the conveyor horizontally. The thing is, a go command or a move command in G-code is giving it a destination. So I could give it like a very, very large destination and it would keep moving. Eventually it would probably reach that destination, and that would be a problem. So instead of using an x-axis move to move the x-axis, I'm using spindle codes. So spinning the spindle to the right or spinning it to the left is M code 3 and M code 4, and then stop the spindle M code 5. So it's treating the x-axis as a continuous circular axis instead of a linear left-right axis, which is what you would normally use. Right. Alistair said, a long time ago I was playing with the idea of looking at the commutation noise from a DC motor to count revolutions. Yeah, I've heard of that being done as well. Austin said, there are some really nice magnetic IC encoders or even motors with built-in encoders. Yes, definitely. And this is the thing, is that I've been experimenting with magnetic encoders for commercial clients. And this is why I'm kind of amazed that the idea never even crossed my mind, because I've been doing it for like absolute positioning on using circularly polarized magnets on the ends of motor shafts for with a hole-based rotation sensor for commercial stuff, which is probably not the way I would do this. Oh, Rob V has made it along as well. Where am I? Okay, so where I'm going with this is, at the moment I have this particular firmware which can accept commands. It can accept G-code commands, and it does what I want. I can home it, I can set it to a width, and I can make it move left or right at a required speed, and I can stop it. So apart from sensor related things and error codes and that sort of stuff, this is really all I needed to do. That's the fundamentals. And so MQTT comms, what have we got? MQTT. Oh, right, so I did some MQTT stuff. What did I have? A call back when an MQTT message is received. Process G-code message. Ah, nice. Okay. Now this is confirming the way my thought process is going. So, at some point, way back when I did this, I implemented MQTT. So let's back it up a bit. We've got this G-code parser here. So we've got parse G-code parameter, and we've got process G-code message. So parse G-code parameter is like a an internal function. Well, these are kind of all internal. Process G-code message. So what we do is we've got an input buffer, which is where the most recent incoming message has been stored. And then we just call process G-code message, and it all gets parsed. I won't go through all the details of this right now, but basically what it does is checks what the message type is by matching based on the things we defined earlier, like G-code home is G28, move is G0, you know, those sorts of things. So it finds which top level command it is, and then it does a bunch of stuff relevant to whatever that particular command is. And if MQTT is enabled, then it reports to MQTT what that particular thing is. So normally this process G-code message is called in serial comms. So we've got listen to a serial stream. This is where the USB cable gets plugged into the conveyor controller, and you open a serial connection and then send it G-code. Exactly like you would talk to a 3D printer or a CNC machine or whatever. We send it G-code on this, and it processes it, and then it does process G-code message. So that is one way that, this is the original way that the G-code gets into the controller. You send it over a serial connection and it gets processed. And then we've got MQTT comms, which has this callback, so that whenever there is a message that is published to the particular command topic that this is configured for, it's got some debugging here that should probably be configurable, but right now it's just outputting it directly. So with this, whatever comes in on that command topic, it just processes it as G-code. So what this allows you to do is either send the G-code through the serial interface or publish it to MQTT, and it will be picked up. So it's basically two paths by which commands can end up going to the same place. In both paths, they end up in process G-code messages. Okay, so that gives us a couple of options. All right, so the next thing, where are we? MQTT. Okay, so what was in my head was I am going to extend this with a third path, and ultimately all of these commands end up in the same place, because I don't want to implement different ways of handling commands from different sources. Like, there shouldn't be multiple ways to home the machine or move the conveyor or whatever. At the bottom level, all of those should be invoked by the same functions. And if I standardize on using G-code for everything, it simplifies that. It means I don't need different parsers for different method types. Okay, so here is what I had been thinking. Where are we? We started on the CANCOM stuff here, but Yeah, I'm going to ignore that for now. So here's what I was thinking. With CAN bus, it is usual to have very highly optimized packets, or frames as they're called in CAN. And I'll show you, actually I will show you this now, because this gives the background of the explanation. So what we've got here is, this is all comments, this is just my notes about the format of this particular CAN frame. As I was writing the thing that formats this CAN frame, this was how I did it. So what you can see, for example, in a non-extended CAN frame, you have 8 bytes for the message payload, which is not much. So what
Waller said my hovercraft is full of eels.
I'm glad your hovercraft is full of eels. So yeah, you can use extended CAN frames, which allows you, I think, 64 bytes of payload. But with non-extended CAN, it's 8 bytes of payload. So the usual thing to do is be extremely pernickety about every bit of the payload. For example, if you wanted to send a status message, the way you would often think about this is that you would send, say, a variable that says whether you have, like, let's look at this as an example. Say at top limit, so bottom limit, top limit, say we've got 4 limits. Left limit, right limit, up limit, and down limit in this particular case. And you want to be able to send whether you have hit those limits. So the obvious way to think about this is send like a Boolean or something to say whether you've hit the left limit. Send a Boolean to say whether you've hit the right limit. And normally that would take a byte. But you can't waste 4 entire bytes of a message that is only 8 bytes long just to say whether you have hit those limits. So what happens is you end up doing lots of bitwise operations, and in this case what we've got is byte 5, and you can see the way I've documented this is byte 5, bit 2, it sets this value, byte 5, bit 3, byte 5, bit 4, and byte 5, bit 5. So we're using bits 2 to 5 of byte 5 to represent 4 Boolean values as to whether it's hit those particular limits. So that is it's a much denser way to transfer the information. So we're using half a byte to transfer that information, and then we've got a whole half a byte left to do other things. So bit 6 and bit 7, for example, indicate whether the controls are enabled or disabled, and whether the valve is open or closed in this case. And I'm sure you can all guess that this is like water cannon related. So yeah, keep out areas and things like that. So just with one byte, so this is byte 5, we have 8 bits, and every bit indicates a totally different parameter. So we are transferring 8 parameters worth of information in 1 byte. So the usual way of doing CAN type communication is with this highly optimized sort of format, where you think about every bit and what you want to use it for. And so in this particular case, I've documented all of this in the code. It's got source ranges and format. Like this is information from the header, PDU specific values and priorities and all of that sort of thing. And then a breakdown of how the information, so this is the header. This is it represented in hex format. This is the header represented in binary. And then there is the payload, which carries all of that information. So what ends up happening is you then have lots of bitwise operators like checking checking this particular bit, so bit 5.5. It's doing an OR operation to set that particular part of the payload. So this is formatting a message to be sent. So it's checking, in this case, if the Y limit has been hit in the down direction, and if it has, it does an OR bitwise operator.
Imogen Ann said 00101011.
Yep. So it does a bitwise operator to set that specific bit within that byte. So at the end you end up with a byte which has its individual bits set by these different parameters. So anyway, that is how I have been doing CAN in the past. But I have an idea for something different, because I've actually been puzzling over this a little bit. I've been thinking about how do I format, or how do I define a format for a CAN message that is then going to go through to the conveyor and that is going to convey certain things. I would have to define what I want my commands to be, what the payload, and then I thought I could be really, really lazy about this. I can be the laziest possible thing and still implement some kind of CAN support for this. And I can do that by okay, so you've little Endian versus big Endian. I don't know, there's an Endian war going on there. So my lazy approach came when I was just thinking about this a couple of days ago, and I realized I could, in 8 bytes, I can just literally send G-code, because I don't need to send long G-codes. If we look at what this actually gets sent, it's really short. Like say we wanted to set the set it going left to right, so M03 space S, and I want to set the speed as, I don't even know what the scale is here, but let's say 100, 123, I don't know. I don't know whether it's like in millimeters per minute or whatever this scale happens to be. So what have we got here? Amazingly, we have 8 bytes. So we've got M03 space S123. We can fit this entire G-code message into a single CAN frame without any packing, without any fancy stuff. So what this means is that I don't need to write a CAN parser. We can do a really, really minimal CAN parser, because what I can do is write a receiving function for CAN that is going to receive a message from whatever other device is sending the command, treat it as if it's a literal, like just treat it as a string, treat it as a chunk of characters, and then call, where are we? G-code. Call process G-code message. So I can receive a command over CAN. Well, at the moment we receive command over USB, we receive a command via MQTT. We could receive the exact same command over CAN, stick it into the incoming message buffer, and just call process G-code message, and we're done. We don't need any decoding in the CAN side at all, other than receiving a chunk of text and calling process G-code message, which makes it incredibly flexible. And it means that if I want to add other commands later, like support for other things, I don't need to change the CAN code at all. It'll just take up to 8 bytes, whatever we send it, and call process G-code message. So if I implement some other function in future, like a command to request the status of the sensors, then yeah, the CAN code doesn't need to change. It'll just be like a new M code definition or something, and the parser can take care of it. Yeah. Oh, Alistair said there's work on a binary implementation of G-code. That's interesting. That is probably something I should think about. But in this particular case, I don't think I need it. So, yeah, sorry, I will, no, I'll see if I can mute that. Denied. All right. Funny thing is, those two message dings that you just heard come in were related to CAN bus stuff. Those were messages from a client, not the water cannon client, a different one, about CAN bus work that I've been doing with him. So, where are we? Okay. So what that means, I think, is that I should be able to implement
Peter Lawler said no, Mongo. Never kill a customer.
No, never kill a customer. So I should be able to do something like just add, I'm going to be super lazy because I always am, and just copy and paste a bunch of stuff. So end if h can, whoop, that is not an underscore. So what I should be able to do is implement some really basic receiver code in here.
Wagon load says how many G-code commands are there?
Not many that we care about. So wagon loads just asked how many G-code commands are there. G-code is very extensible, and you can do a huge amount with it. But in this particular case, we're dealing with an extremely limited subset. So the ones that I have defined, this is it. There are 5. There's G28 to home, G0 to move the conveyor to a certain width, M0, M03, M04, M05 to make the conveyor move right, move left, or stop. And that's it. So those 5 G/M codes are the only ones that I care about at this stage. I may well add others. For example, I might add, I don't know, I'm just going to make up M10 with no argument. Oh no, let's say M10, I don't know, S, I really shouldn't be doing this on the fly because I'm not thinking through. Requests status of a sensor at position. I'm going to delete this because it doesn't actually, or maybe I'll just like put a comment within the comment. So there might be a command later where we send a G-code that's like M10 space S1, which requests the status of the sensor on position 1, which could be the input side on the conveyor or something. So there are other things that we might want to add in future to allow for that, but that's not implemented. Right now, only these 5 matter. So what I could do, where are we? CAN comms. So in here, what have we got? I'm going to need to include that. So we've got MQTT comms, we've got serial comms, and we're going to do include CAN comms as well. And right now that won't actually do anything. In fact, before I do anything else, I should check if this compiles because I could be working with broken stuff. What have we got? ESP32. I want to go for the S. Oh, come on, come back here. Oh, come back. ESP32 S3 is the module that I want. In fact, I wonder if there is a particular profile for that touchscreen board. I can't remember. I think it's just an S3. Wagonload said, can you define G-codes as 2 digits so you can compress G-code commands to shorter strings? Yeah, well the thing is that I can arbitrarily define any message that I want. Using G-code is just like a convention. So, where are we? Port, no, port doesn't matter. Okay, so let's just see if this compiles first. Yeah. Michael says, does it have to apply to every customer? I have a list. That's a callback to the comment earlier about don't killing a customer. Wagon loads. Can you define G-codes as 2 digits so you can compress G-code commands to shorter strings? Yep. Yeah. Well, funny thing is that that particular customer, there is a non-zero chance that if I screw up my work, I could kill them, like literally kill them. And I really don't want to do that. It's still compiling. Hasn't looked like it's failed so far. Now, I wonder if I should actually load the code onto this thing. Maybe I should, because then we could, I've got a USB cable going somewhere. I had a USB cable going somewhere here that I could plug into, but I don't know where it is. I'll have to look around. Oh, there it is. This is the USB cable. It's plugged into Xeon's Bling, which is back in its enclosure now. So I can use that USB cable to plug it in. Okay, so it compiled. That's a good thing. Michael says, I've seen fudged up CAN bus command slam the brakes of a truck on hard. So yes, the problem is real. Yes. Yeah. Oh, I so wish I could talk about this project. One day I am going to be able to reveal this secret project that I've been working on for like the last 6 or 8 months. And it is going to blow your minds. It is so cool. But yeah, NDAs with consequences. I really can't. I can't even hint, other than the fact that it uses CAN bus, and that if I screw up, people die. So, yes. Yeah. And the thing is that recently I've been seeing things like press releases from one of the end recipients of this technology, because I'm contracted to like an R&D company, which is doing the early stage, which is doing the work, which then will feed into OEM production of this technology, and who then sell it to the end customers, and the end customers are at the stage where they're starting to do announcements of things, and yeah, I can't say that I'm working on it. Now, where are we? Okay, so I was distracting myself there. CAN comms. All right, so this, I can plug this in and...
Austin's _creations said crack the code to self-driving vehicles.
No, not self-driving. This is... Sorry, I'm mentally going backwards and forwards on whether to take the time to plug this thing in and start talking to it, and then I think it probably is worthwhile. I want to get some debugging information out of it. All right, so what I'm doing is plugging in the conveyor controller prototype. I'm just going to plug this into my computer, and is it running? Yes, it's up and running. Okay, so there's power on the touchscreen at least. Do we have a serial port? We don't have a port. That's interesting. I wonder why the port hasn't come up. I wonder if it is not powering off there. I don't know what state I left this in. In fact, what I'm going to do is remove the... Okay, I've removed the back PCB. So this is now just the WT32SC01 touchscreen module with USB plugged in and nothing else. So I want to be able to... But I don't understand why it is not currently coming up as a serial port. What is wrong with it? I wonder if this one's busted. That is a distinct possibility. I might grab a new one out of the box. Out of the box. Where do I have them? Oh, I think I've got a couple of spare sitting in on my stock shelf. In here. Where? Touchscreens. No. Yes, my brain has stopped while I'm searching. USB hubs, not there. USB, oh, there we go. Okay. I found a little box with the touchscreens in it. Do I have another one? Okay, this is my little box that has a few in it. Yeah, looks like.
Until I said turn it off and on again, it usually helps.
Yep, it usually does. Okay, so I believe this is a brand new one straight out of the box. And the way we will know is these things come with demo firmware on them. Oh, there we go. It's come up with the demo firmware. So it turns on the back light. Oh, it's got a, yeah, the unlock is this game where you drag the icon along the line. There.
Unexpected Maker said, whoops, missed the start. I'm on the line making tiny S3s.
Aha! Nice one, Sion. Keep those machines running. Alright, so this is a brand new out-of-the-box thing. Now let's see if we've got a port. And we still don't have a port. What is going on with that? I think there must be something... maybe this is a power-only cable? That's possible. That is distinctly possible. So I'm going to find myself another cable. I'll plug this one in. In fact, I'm going to plug it back into the original because I want to be sure that this one is working. And also this original one, I have...
Austin's _creation said use the cable tester I sent you.
Yeah, I should. So this one I have soldered nuts into. So this one has M3 nuts soldered onto the PCB. The normal WT32 SC01 just has these big holes where you can put solder nuts in, and this one I've fitted them. So this one is the one I have been using, and I'm going to try connecting that again. So I'll plug it in on this other cable and we'll see if we get a port appearing. Port, still no port. Hello. I really don't know what's going on with this. This is definitely a good USB cable because I've used it before on, in fact, I just unplugged it from the programmer that I was using it with. So, anyway, I'm not going to mess around with this too much. I might give up on this and... Oh, Tradie Trev says needs to be in boot mode. Yeah, but... RST, there is no... This is an S3 on the back of this. It's a... or is it? No, it's a regular ESP32. Okay, so there's a reset button. There's no boot mode button on it that I can see. It's a long time since I've looked at these, so I don't remember. But yes, you're right. It does need to go in. Well, no, it should come up with a serial port, even if it's not in boot mode. So, and I'm not seeing anything at all. My computer is just not enumerating it. Anyway, what I might do is just mess around with the firmware and and maybe be able to.
Unexpected Maker said it'll be auto reset, but serial should be there with an external UART chip.
Yes, that's right. The port should be appearing on my computer. It looks like it's got a CP something. I'm going to check under the microscope. Let's see what this has. Oh, my microscope camera is not turned on, so I won't bother switching to it. It's a Scilabs chip. Yeah, it's a CP2104, which should just appear as a device.
Imogen Ann says, tell Imogen Ann.
Yeah, anyway, I don't know what's going on with that. So what I think I will do is totally screw this up live and embarrass myself. So what I'll do is, oh, that's just send. Where's the, oh, okay, I don't have a receive can message function yet. So what I can do is I'm going to take a chunk of code. Oh, Wagon Load says, I had a problem where I saw the board listed on my port, but it still wouldn't upload.
Imogen Ann said please consider feeding the Petertham with forbidden reflow pizza.
Forbidden reflow pizza. I was going to say that's the best pizza, but no, I don't think it is. So let's see what we can do. Void read. I got to decide on my my formatting. Amanda, you're here. Thanks for coming along. Oh, and Luminator is here as well. Celtic Beast is here. Gilted, Dave Paul Jones. A few people have joined the stream since I said hello to everybody earlier. Yumi says air fry pizza is the best. Yeah, air frying pizza is a very good way to reheat it. Read can messages. This is an area where, so I normally try to follow the embedded C coding standards from, oh, what's his name? I can't remember. I've gone blank on it. Embedded C. Come on, it's got to be bar group. There it is. So this document here. Oops. I've talked about this before on streams and things. This is what I normally use as my guidelines for coding, with a couple of variations from it. And
DIY in the ghetto says don't forget me disappointed.
Oh, DIY, you're here as well. I'm sorry, I didn't see you there. Late to the game, but you're here. All right, so yeah, I normally follow the bar group embedded coding standards. That's just my guideline for doing things. But one thing that does not feel right, and I kind of understand why he does this, but he uses the same formatting rule for function names as for variables, and it kind of breaks my mind a little bit, because I'm kind of used to doing things like read can messages, you know, some thing like that. And then, in fact, in this case, because can is an acronym, it's like the camel case ends up capitalizing the can as well. So that's a bit of an oddball example. But this is kind of how I prefer to write my function names. But that is actually in breach of the bar group standards. So I'm going to do it that way. So I'm going to... So what I'm doing here is... let's write a little explanation here. Callback that will be invoked when a can frame is received. All right. So this is going to handle whenever we get a frame coming in. So later, I haven't done any CAN bar setup yet. This is like starting from the end of the process and then working backwards. This is once we've got a message in, what do we do with it? How do we parse it and then action it? But we're not even going to receive any messages because we're not doing any CAN initialization. We haven't done any of that stuff yet. But
Unexpected Maker said, I much prefer snake case, but it pisses off all the C++ snobs.
Snake case, yes. Yeah, so snake case, is that when you just capitalize the first one as well? It's like camel case, but doing it at the start. Yeah, I actually find it easier to read this. I think it is weird when the first one is lowercase like this. So I would be perfectly happy like this. That actually makes a lot of sense to me. No, snake case names. Oh, snake case names? I see. So you're talking about when it's, yeah, all name underscore, etc. Wagon Loads asked, would JSON work with CAN bus commands? Short answer, yes. Long answer, no. The reason for the short answer is that you can pass anything you like over CAN bus. If you wanted to, you could just, like, yeah, at its most fundamental, it is just a way of moving bytes from one place to another. So if you wanted to transfer JSON, sure, no problem. The only thing is that JSON is very verbose. So it's, because it is kind of self-describing.
Amanda Thompson said, can you send a link when I can find the standard document, please?
Oh, that is a very good point. Amanda asked if I could send a link to the bar group programming standards. Let's, I will find it and bar C, hang on. This is not actually their thing. This is someone else. Oh, this is Perforce talking about the bar group coding standards. Developing bar C compliance, where is, but this is not, that's just an introduction to it. Okay, bar C, here we go. Embedded C coding standard, and I don't know if this is the most recent. Probably is. All right, I'm going to drop this in the chat. Bar group C coding standard. There. Okay. For anybody that wants to mess around with that. So yeah, you can just grab the PDF. The PDF is what I had open. I have a copy of it on my computer and I pull it open whenever I want to look something up. Yeah, in the past I've talked about things like doing comparisons. Like just as an example, it's really common to do something like if my variable is equal to my define, like that sort of thing. So this sort of structure is really common. This is in breach of the bar group standards because it puts the constant on the right and the variable that you're doing for the comparison on the left. And what you really should do, I'm going to copy that, stick it here. What you really should do is go my define equals that. So yeah, there are lots of little things like this which the bar group standard calls out, that when you first see them you think, what? Why would you do that? It doesn't make sense, because what you're doing is you are checking whether my variable is equal to that, you know, like predefined value. And that is obvious. I mean, why would you do it backwards like this? But when you read into the explanation, like the reasoning behind this, which I'm not going to get into right now, I've talked about that on a previous stream, it actually makes a lot of sense, and it catches, doing this convention has caught bugs in my own code multiple times. This convention has saved me. So yeah, this is how I always do it now, instead of like that. So let's get rid of that. Yeah, there is a lot of thought behind the bar group embedded C standards. So right, now what I'm going to do is, there are some, getting back to this, read can messages. Okay, so at this point what we're doing is making a callback that is going to be invoked when a message, or when a frame comes in. So packet size is equal to can dot parse packet. So we're going to check how big the packet is, and everything. So this is basically just a check. So what I'm doing here is I am cheating because I'm cribbing off code. I've done lots of can stuff in the past, so I'm just working off if packet size. I'm working off things that I already know work, and then I'm just going to sort of flesh it out from there. So what we're doing is, this wrapper is going to be around everything in our function, and it just checks that we really do have a valid packet and that it is a non-zero length. Probably unnecessary, but what the hell. Let's have the extra check in here. So if we have a non-zero packet size, then we have something to deal with. And what this catches is situations where a frame for whatever reason might have arrived, or we might have invoked this callback, but there is no packet in the buffer. Like the buffer might have been cleared for some reason, who knows what. It might have happened external to this. So we want to, we know we've been called at this point. We don't actually know for sure if there is a can frame sitting in the buffer. So we're going to parse the packet, which returns, when you with this particular library, or the one that I'm about to use, if you do parse packet, the response is the size of the packet. So we're just checking that we really do have one. This is like, if you're processing a serial command, this is like doing if serial, you know, checking if there's something in the serial buffer. So what else are we going to do? Let's make a buffer, and we've got 8 bytes to play with. So what we're going to do is stick the message that we've been sent into this buffer, and the most it can ever be is 8 bytes, just with regular can. So what else are we going to do? So when you start looking at this, you'll see that it is remarkably simple, remarkably similar. What's the time? Okay.
System notification.
Halfway through.
1 hour remaining.
Yep. So what I can do, yeah, this is like reading from a serial buffer, and effectively that's what can is. It's kind of, it's like a really fancy serial connection with a whole lot of prioritization and collision detection and addressing and filtering and stuff all sort of built in at the low level. It's just a very, very reliable way of getting serial data from one place to another. So we can do basically the same as like reading from a serial port. Okay, in fact, if we go to the serial comms here, you see here we've got while serial.available. So while there is something on the serial port, read it. So we're doing, we're pulling receive char. You can see that I didn't follow the bar group standards here. Receive char, it's just reading from the serial port and then printing it for debugging purposes. Oh, I should do that. Why have I commented out my debug stuff there? Okay, adds it to the buffer. I can feel a sneeze coming on. It's going to be here before long. I apologize in advance. Now, okay, so in the same way, basically, it's looping around and pulling bytes off the serial port. We can, I just got a message from Sion. I'm very tempted to stop and read it, but I won't. I will try to resist. Yeah, in the same way. So, same way as we've got listening to the serial stream is while serial is available, we are reading characters. In our CAN code, we're going to do the same thing. So, if packet size, because the frame comes in as a complete frame, it's not character by character, we've got a frame to work with, which could be up to 8 bytes
Mitchell
in
R.
length.
said as punishment, read it live on stream.
Read it live on stream. Then
Unexpected Maker said it's kinda stream rel.
kind of stream rel. Okay. All right. I'm going to open messages on my computer. Oh, I shouldn't have done that. It opened in the wrong window, on the wrong screen. Okay. I am going to, okay, this is how I'm watching your stream on the line. All right, I've got to bring this picture up.
Mitchell Oss said do it.
Here it is. So this is Sion right now running his pick and place line. And you can see there's the touchscreen controller on the left for the Juki pick and place machine. That is a screen, that screen on the right that's partly covered by my head. That's an optical inspection sort of thing. So you can see there's a down camera and there's no board at the moment ready, but you can see the camera pointing down into that location. And a laptop with my ugly face on it. Cool. So, where are we? Okay, back here. Okay, so it's taken me a lot of talking to get to the point of writing the next line of code. Let's say we need to keep track of where we are. So we'll say uint.ti equals 0. That'll do. So we're going to start ourselves an index. And then while can.available, we don't actually know how many bytes are in the payload. We could calculate it, but screw it. We're just going to read each byte as it comes until we hit the end of the frame, rather than, like, we've got the packet size here, but it doesn't, we don't need to use that. That was just to check if there is a valid packet. So what we can do then is do can payload. So this buffer that we just defined earlier, and we're going to say that is, we're going to cast to a char and read it from the can. So this is just like serial.read, taking a byte from the serial interface and sticking it into a buffer. We are taking a byte from the can frame and sticking it into the buffer. So this, by the end of this, we have a buffer that will have been populated with the bytes that have come in on CAN bus. So let's start setting some other things up. Config. I want to be able to turn on debugging for this. Backlight. I don't have any debugging flags. Maybe that's why I commented that other thing out earlier. If I try to compile this now, it'll probably fail. So back in serial comms, I had, if debug. Yeah, I want finer grained than that. So where is debug defined? Where is debug? Is it even defined in here? Come on. Debug. Is it defined? It's not. All right. In that case, let's start setting ourselves up some things. Debug serial, I'm going to make that false, fails, and define debug can, I'll make that true, and on the serial, I had debug if and def debug serial. That's better. Okay. So now we can selectively turn on debugging on the serial and turn on debugging on cans. So let's say if def debug can and end if. So now we can see what we have received on that buffer and stick it out the serial port. So we can do, what should we do? Debug. Let's just give ourselves some space first. And should be able to just, what do I do? While, no, I'll do a for you and 8, can't type, ATJ, I'm already using I, so let's just use J. J is less than 8, we'll do J++, and I'm going to do serial, serial.print, where are we, can payload, J, not I, J. And what I might do is print that. I've got to think about character formatting here because we're going to end up with hex bytes. We want to treat it as ASCII. There's going to be some screwing around here when it comes time to actually figuring this out. I'm just going to have to send it some messages and see what comes out the other end. So we can do serial to print. In fact, what I could do is, let's do it like this. Serial.print 0x blah, and then that, and then serial.print. In fact, I'll do that as, what's the formatting for serial print? Is it like that? I think it is. So I can force it to print it in hex, because I want to see the raw hex values, and then we can figure out if they're ASCII equivalents or whatever. There's going to be some messing around. Serial.print, and then I'll just do a space at the end. That'll do. In fact, I'll, yeah, and then after that, serial.print line. So hopefully this, unless I have totally screwed this up, what do I think we should do? Okay, so we're clearing the line, we're making ourselves a loop, we are printing the payload of that point in the buffer, preceding it with a 0x just for formatting. I could have done this with sprintf. Screw it. Then a space, and then a new line at the end. Hang on, cough coming up. I think that makes sense. All right, so in order to compile this, I'm going to have to include the can library. Which one? There are a few different can libraries. The one I normally use is by Sandeep Mystery. Let's see. So let's stick it in here. Include can.h by Sandeep Mystery. Because I always specify this because it can be really confusing trying to find different can libraries. There are a whole lot of can libraries that are all derived from the same sort of upstream work, and the one by Sandeep is the one that I've most commonly used. I've used a few others as well. There's a DF robot library that I've been using on a different project, and but this is the one that I normally use on ESP32 can projects. So let's, what did I just do? Did I just hit something by mistake? I don't know. Let's see if it compiles. Probably won't. There will be an error somewhere. Waiting for the big red mark. Okay, I've got to have some of this flat Coke. Flat Coke left over from the last barbecue. Because I don't normally drink just regular Coke. So it ends up sitting in the fridge. Oh, what's going on in the chat? What is going on in the chat? Look at last question. Okay, Wagon Load says, looking back at Wagon Loads, Wagon Load says, can you define can commands so that once defined they work as an interrupt, so they don't need to be looked up each time? I'm not... Okay, I've got to think about that one. Oh, Andrew and Wendy, coming in halfway through to wish you and Steve Steph a Merry Christmas and peaceful New Year. Thank you, Andrew and Wendy. I don't remember seeing this name in the chat before. So, welcome. Hang on. Okay, so there is an error compiling, as I expected there would be. What have we got? Multiple libraries, can, blah, yeah, blah, blah. Oh, it'll be because I'm not actually there's no can object. How obvious is that? Like even before scrolling back to the start here, yeah, file included from error. It's throwing me all sorts of can library errors, and that is because, yeah, I'm calling an object that does not even exist. So, what am I going to do? Okay, I'm just going to have a look at how I've done this. Can.begin, where is it? Okay. Can. All right. I am cheating and looking up a reference to see how I've done this. So we've included the can library, then in the begin, in setup, I want to, it's doing all the graphic stuff, blah, blah, blah. Where am I going to put it? Somewhere a bit down after starting Wi-Fi. We can do it pretty low down. We've got the OTA handler there. We got setting up MQTT client. Let's do it right down here. This makes logical sense to keep this group together. Set up the can client. Well, it's not really a client. Set up the can interface. That describes it better. And then we can do can.begin. I'm going to make it
System notification, 45 minutes remaining.
Oh, actually, there's a bug here in the can code on ESP32. So, okay, I'm going to do this the simple way. This is not actually, I don't think this is actually going to work. So we kind of need to wrap this in another check. Okay, I'm going to work it up in stages. I'm going to work it up in stages. So I'm going to say if not, and serial.println can failed. Oops, that's not what I was trying to do. Else, can't type good. Serial.println can initialized with good Australian spelling. All right. So what this will do is set the can speed to 250 kilobits per second. In theory, it doesn't actually do that. Now, do I need to create a can object, or is that done? I'm just going to try compiling this. I can't remember if creating a can object is handled automatically by the library. I have a feeling that it is. And then we just have to call begin on it because we've already included the library. So let's see where it bails. All right, not used, not used. Multiple libraries were found for can.h. What is it failing on? A whole lot of stuff. Oh, can rx. Oh, I haven't declared all sorts of stuff. Of course, of course. All right. This is very. Where are we? Where am I going to define it? Conveyor, ready in, ready out. Let's. I don't know. Let's stick it up here somewhere. This will do. I've got to define can bus. I haven't defined pins. I haven't done any of the proper setup stuff. So let's let's get this set up. Can pins, can, I'm just looking at my cheat sheet here, the one that I can't show you. Can speed. Now, okay, I'll define can bus speed as 250 E3 so that I can make this in the config, because in here, where were we? Not there, not there. It was down near the end. Okay, so here, I want to make that configurable. So we're going to be able to set the CAN bus speed in the config file. We also want to set some pins yeah. Sorry, what's going through my head is I'm wondering whether to gloss over the whole fact that this is just blatantly not going to work. Now, technically, this is how you should do it. You should be able to say, I want to run at 250 kilobits a second. And so this value, it might not look like it makes any sense. 250 E3 is a define within the CAN library that sets up some parameters.
Said, I've never even looked at CAN bus. Is this using the 32 Spanish pesetas twice stuff? Or are you using a separate CAN transceiver receiver?
That is a very good question, Sion. So this is using, okay, so background. I am using the built-in CAN controller with an external CAN transceiver, and it is using, so it's using the, what Espressif called the TWAI interface. So TWAI stands for Two-Wire Automotive Interface, and it is simply a name that they invented to get around calling it CAN bus because they didn't want to pay license fees. Well, there's some IP related issue. It's like Like I think this is actually the same thing that happened with the wire library in Arduino. So in Arduino, if you want to invoke an I2C device, like say you want to open an I2C connection to a peripheral, you use the wire library. Now wire is an implementation of I2C, but it's not called I2C because they didn't want to call it that, because then they've got to pay fees to the I2C consortium or whatever the thing is. Now, I may be wrong about that, but that's my understanding of the history behind the wire library being called wire instead of I2C. And similarly, TWAI is Espressif's rebranding of CAN bus. It's actually more than, well, to be fair, it is more than CAN bus because it also encompasses LIN bus, which is a sort of like a derivative subset of the CAN interface. LIN bus is a simpler, cheaper to implement bus, similar to CAN, but it's used for very low cost, low throughput devices. So TWAI, the two-wire automotive interface library from Espressif, supports CAN bus, LIN bus, and I think other stuff as well. I can't remember. Anyway, what I'm doing is on this carrier board, on this board, which plugs into the back of this. So this has got an ESP32 on it, and it's got I/O broken out to these headers. I'm using the CAN controller, which is internal to the ESP32, and connecting that through to an external CAN transceiver, which you can just see, it's up here. It's that little 8-pin, it's a SOIC 8 device just above that little green jumper below those white JST headers. That is the CAN transceiver, which does the wire level signaling and buffering onto the CAN interface, which is on this green header here. But I'm using
Unexpected Maker said, okay, so even though there is a controller in the 32 Spanish pesetas, you still need to add your 1TX RX chip.
That is exactly correct. So CAN consists of, a CAN interface typically consists of two components, if you don't count the microcontroller. So there is the microcontroller, which you need obviously. Then there is the CAN controller, which the microcontroller talks to, often using SPI if it's an external one. And the CAN controller then talks to a transceiver. The transceiver is just like an electrical buffer. And the reason they are separated is that you might have different isolation requirements. The CAN controller can work with different transceivers depending on the electrical characteristics of the bus that you're talking to. Because you might have like a fully opto-isolated CAN bus, in which case you use a fully isolated transceiver, or you might use a low-cost transceiver if it's like a non-isolated bus. You might have a floating ground situation where you don't want common ground between the devices on the CAN bus, or you might have a common ground. So in all those sorts of things, the transceiver could vary and the controller can stay exactly the same. It's like the PHY, like the physical interface in Ethernet versus the Ethernet controller. It's basically the same sort of major blocks if you're looking at it from a logical point of view. So Sion asked, so there is no way to use any ESP32 I/O as the transceiver. You always have to have an external one. Yes, that is correct. And the reason for that is that CAN is a two-wire, well, technically it's a three-wire differential signaling system. So the bus floats at 2.5 volts. Both the CAN high and CAN low signals are at 2.5 volts, and then they are driven 1 volt above or 1 volt below. So they're driven down to 1.5 volts or up to 3.5 volts, so that you get a 2 volt differential between the two signals. So normally both CAN high and CAN low are sitting at 2.5 volts, and you drive CAN high up to 3.5, and you drive CAN low down to 1.5, and that 2 volt gap is what indicates bits. So they go between 0 and 2 volts differential. And all of that is taken care of by the transceiver. So you don't actually have to care how that's implemented. Now there are transceivers, the ones that I commonly use have a run at 3, so most CAN transceivers for that reason run at 5 volts. So you need a 5 volt rail on the CAN transceiver because it's got to drive CAN high up to 3.5 volts. But you can still interface to a 3.3 volt CAN controller or microcontroller with a built-in one. And you can also, depending, you got to check the specs on the particular transceiver, but you can also get 3.3 volt CAN transceivers, which seems like a magic trick, but they've got a little charge pump built into them so that they can drive the CAN high slightly above their own supply rail. Yeah, and CAN is kind of forgiving anyway. You can actually disconnect one CAN line and it'll probably still get data through. Where are we? CAN bus speed, okay. So Wagon Loads asked, is CAN bus better than I2C if you want to talk to different boards that might be at different potentials? Absolutely. And they are really intended for very different use cases. I2C is typically very short connections. It was originally intended only to be used on the same PCB. It was never intended to go off the PCB onto other devices. And the fact that it's used that way is kind of an abuse of its original design requirements. It's just a testament to the fact that it works so well, like to the design. So CAN is designed to be able, so I2C is designed to run local interconnects between integrated circuits on the same PCB. CAN is designed to run signals a kilometer away on a different, with a different ground reference past big motors and in noisy industrial environments. So they are very, very different in terms of their requirements for noise rejection and brain not functioning, error rejection and correction and all those sorts of things. And with CAN, you can do fully opto-isolated I2C, of course, but CAN is really designed to be used in those nasty industrial sort of applications between big machines on a production line or linking parts of a robot or something like that, whereas I2C is not designed to have that level of noise immunity.
Mitchell S. said you can he.
Yep. Because Mitchell's probably been doing opto-isolated I2C. What am I doing? Can. Okay. I was... now, I'm going to have to look up some pins. Now, I'm going to have to find CAN RX pin. I'm going to have to verify if this really is what it is. CAN TX pin. What do we need? So we need to set up RX and TX. And this is because, hang on, why isn't that even being used? CAN RX. I'm trying to remember how this comes about. So if we look at CAN, sorry, I'm just looking at something else here. Oh, what's my time?
System notification. 30 minutes remaining.
Okay, 30 minutes remaining. What have we got? CAN bus speed, RX time. There's a whole lot of complication here that I'm kind of just ignoring at the moment. 4 and 5. So this, I think, so I'm trying to remember how I did this. A fair bit of this I'm cargo occulting from work that I did years ago, so I'm trying to remember. I'm just going to try compiling this. I think what happens is that if you define CAN RX pin and CAN TX pin, that then gets picked up in the CAN bus library rather than, yeah, which is a little bit odd. It's not like a regular way of configuring a library. Multiple libraries were found. What am I screwing up? Do I have the actually? Oh, I've got the wrong processor selected. That is probably why this is freaking out. Let's see if it compiles now. Come on, I'm just waiting for it to switch boards. Let's see. So wagon loads. Oh, hang on. What happened then? I don't know what happened then. I'm just going to leave one of these plugged in and maybe it'll pop up as an actual port at some point. Okay, compile. Now there was a question from Wagon Loads. If I wanted to design a power supply with 3 floating outputs with the boards acting as masters and slaves, which is better, opto-isolated I2C or CAN bus? If it is within the power supply, I would use I2C. It's just simpler to implement. You don't need... well, actually, I was jumping to a conclusion then, but the conclusion I was jumping to was that you are talking to other I2C devices, but that may not be the case. If you are building all of these boards within your power supply and you want to have them communicating with each other but separate, like isolated, you might... Even I2C might be too complicated. You might be better off just using something like RS485. Like just make it a simple serial connection. If you've got a microcontroller on each of those boards and they're talking to each other, if you're talking to I2C devices, then just go with that. That'll be the simplest thing by far. But if you have to implement the firmware on each end, I2C is kind of an added complication you don't need. I would just make it a serial connection between the processors. If you were wanting to have multiple power supplies physically separated and maybe in an industrial sort of environment, then CAN bus could be a valid way for you to link them. So the way I think about it is I2C for internal onboard, CAN bus for external stuff. And this compiled. Wow, that's kind of amazing. So where are we? Okay, so we've got read CAN messages. All right, so we've got the callback that is checking that there really is a frame. It's sticking it into the buffer, and then hopefully the debug is printing that buffer out. So it's not going to do anything with it. It's just going to tell us that it received a message and what the message was. That's it. And then later, down here somewhere, do something with the message. And this is where we're going to, what was that function called? Parse G-code command or something? I can't remember what that was called. Let's say stuff the message into the receive buffer. That's going to have to be done after a bit of formatting. Now, where is it? G-code, 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 parse G-code parameter. This is it. Process G-code message. Is that what I said? I don't know. G input buffer. Okay. So I want to, where are we? Parse G-code, there we go, parse G-code message, that's what it is. So I'm going to want to call that but I'm going to want to stuff it into what was it, message buffer. I'm just putting all this stuff in here in comments for myself for later, because this is what I'm going to have to deal with. But we're not there yet. We need to do some other things. Like we need to actually call this callback at some point. We need to set up the callback. What was I doing? G-code. G input buffer. That was, yeah, that was what it was. So it should be, so at this point we should have received a message. And what we want to do is take that message and put it into G input buffer, and then call process G-code message, which then acts on that buffer. So that buffer can be populated in multiple places. It can be populated from serial, it can be populated from MQTT, and in all cases we simply want to call process G-code message once we've got the message into the buffer. So we should probably do some sanity checking on here. Sanity check the message. Maybe, I don't know. Check for some parameters. That's already kind of done. I don't want to do too much in this function. What I want this function to really just transparently take whatever comes in on the CAN bus and pass it off for processing by the G-code parser. And the G-code parser itself does pattern matching, so it figures out if the message that it has received is sensible, and if it is, it acts on it, and if it isn't, it ignores it. So we've already got that checking, and I don't think there's a whole lot of point putting checking in multiple places. Oh yeah, Sion also pointed out, also this is, I just saw Michael's comment, wow, it compiled. Old programming proverb. Yeah. Yeah, Sion pointed out, also depends on the speed you need to communicate. RS-232 could be much faster than I2C as well, right? Yeah, I believe so. So, yeah, there's no need to overcomplicate things. If you've got multiple microcontrollers and they are within the same device and you want to communicate between them, then some simple serial communications is probably the way to go, because the most microcontrollers have hardware UARTs in them, so they'll have built-in buffering and all of that stuff, and processing serial messages is quite simple. Now, okay, so I'm not actually going to implement any of this stuff right at this point in time. I am going to come back to that, but hopefully what I've said there is what I will need to do. Okay, so how are we going to call this? Oh, excuse me. How are we going to call this, invoke this callback? Read CAN messages, yeah. Okay, we'll just do it in, so we've got listen to serial stream, set mode conveyor speed. We'll do it here. So we've got MQTT messages that are being handled by an MQTT callback. We've got listen to serial stream, that's listening to G-code coming in on the USB serial connection. And then we'll do read CAN messages here. So this is in the main loop. So the loop is just looking for MQTT, or keeping MQTT connected. There's an over-the-air update thing. Let's ignore that. It's looking for messages from the serial connection, looking for messages on CAN bus, and then it is setting the speed based on whatever has been most recently parsed out of different messages. And then of course when a message comes in either on the serial stream or CAN or MQTT, it gets processed by process G-code messages, and then that then calls out to things like home Y access, or what's another command that it does down here? Where is it? Where does it do something useful? Y-axis step. So yeah, all that stuff. It does all the different things. So CAN comms. All right. Now, in theory, we are at the point where we could plug this into a CAN bus network and send a frame, and it should print that frame out. Now, there are some fairly important things that are missing still. One of these is any form of filtering, because what this is going to do is it is going to accept any message that is broadcast on that CAN bus. Now, because CAN is a bus, it is not a point-to-point connection, although you can use it as a point-to-point connection. The general idea, or the usual use case, is you have a whole lot of devices all connected on the same bus. And that means you need some way of differentiating who is talking to who. And when you send a message, the message has a header. The header specifies who it's coming from, so it's your own ID. And then you can also specify a destination ID. And then you can filter based on different parameters. So in this particular case, what we're doing is we're not filtering at all. Reading CAN messages is just taking a packet and sticking it into the CAN payload buffer and then printing the buffer. So this, effectively what we've done here is we've made ourselves a CAN bus sniffer. It's just going to, whatever comes in, it's just going to dump it out on the serial console. So that is kind of useful as a first step, but we want to do some filtering so that this device has an identity on the bus and we ignore messages that aren't sent to our identity. So, let's see, PDS specific source address. I'm just looking up my little cheat sheet here for how we do this. Oh, just checking chat. Wagon Load says, oh, okay, my master slave power supply board is on Discord and BitLooney Labs Crunchy Bits. Okay, interesting. Power supplies are always interesting. I'm kind of curious to see what you've done. Wagon Load says, I made an ESP32 PWM control power supply, which is an onboard I2C ADC for error correcting. I want the ADC to only be seen by its own ESP, but not by the master. Okay. Can you just have multiple I2C buses? I don't know. Oh, Wagon Loads also said, CAN bus to from messages sounds like HP messages. HPIB? That's the old standard used for lab instruments, isn't it? It's a long time since I've looked at that. So that standard eventually evolved into something else that I can't even remember the name of. And I was looking at fairly recently, there is a lab instrumentation communication standard. Hang on, another cough. Ah, that's better. All right, my silky smooth voice has returned. These are the sounds of Night Vale. All right, okay, so filtering. What should I do? I think I'm going to source address. Yeah, let's set some things up here. Ooh, not much time left.
System notification. 15 minutes remaining.
Yeah, I'm looking at the boundary I'm working within. So if packet size, so that means that we have a packet. So all of this code here is what we do if we have a packet. So let's say, I keep saying packet, I should be saying frame. I'm using Ethernet terminology instead of CAN terminology. All right, so let's do a thing here, UN16T. What I'm okay, the way I'm thinking of doing this is doing this as like a nasty, hacky version of J1939, which is a vehicle type protocol. So J1939 source address is can.packetid no ID and 0xff. So what I'm doing here is the so can packet ID when the can frame arrives, or a can packet arrives, it has a number of attributes in the header, and they are packed into a couple of bytes, because the way the header works on the can frame, it's not necessarily on nice byte boundaries. There will be a few bytes that contain a whole lot of information, including some header information. So what this is doing is setting a variable called J1939 source address, and it is doing it by extracting some information from the packet ID. And we are not doing anything with this yet, but we can now use this as a comparison to say what is the source address of this frame, and therefore do we care about it. So I'm not being used yet. Just going to leave that there for future reference. So right now this is not being used. We're just, and I'm deliberately not going to use it to start with, because I want during my debugging to be able to see everything. It's if I start applying a filter at this point, I might have screwed up something in the addressing, and then I'll never see a message and won't be able to debug it. So at least this way we can, in fact, let's do this. Debug can. Let's do serial.print line. No, not that. Not in quotes. I want that. So that'll just print the source address that it has extracted. I probably want to do that as hex, just for ease of readability because of the way things are formatted. What else do we want to do? So this will give us some, later on once we start sending messages to this will give us information about what those messages are. Okay. Oh, Stephen says, off to make a PAV for Christmas today. If I don't get back before the end of the stream, have a great Christmas and see you all next year. Thank you, Stephen. Enjoy your PAV making and then your PAV eating. And hopefully I'll see you at the next barbecue. What else is there? So, Wagon Load says, in modems, AT is the modem attention command. Yeah, at for attention. What are we doing? Okay, I think we have enough here in the callback for debugging purposes. This is enough for us to start sending messages to this device and have it display them. However, earlier I mentioned a couple of times that there is a problem with CAN and where are we? If we go into config, here we go, CAN bus speed 250 E3. Now this is a very sad situation that I wonder what it will be. These these particular touchscreen modules, sorry, my brain is going off places. These particular touchscreen modules probably will not exhibit this bug. But anyway, let's allow for it. Let's allow for it. Okay, so what we have here is, if this bug didn't exist, which I will explain in just a moment, this chunk of code would work. So we're saying, if not can begin, can bus speed. And then, so if it's failed to begin, we'll say can failed. If it, otherwise, it worked. So the problem is, if we define CAN bus speed here, and here we've got CAN bus speed as 250 E3, so 250 kilobits a second, we will not get 250 kilobits a second. It'll give us 125 kilobits a second. But only if it's an ESP32 and the silicon version is greater than, is 2 or more. So with the early ESP32 silicon, this would work perfectly well. And then there is a bug somewhere, I don't know if it's a hardware bug or a software bug or what it is, but if you use this code on recent ESP32s, you get half the CAN bus speed. So the fundamental reason for this is that there was a flag that was added that allowed, it was like a divide by 2 flag to halve the speed of the CAN bus to allow a greater range of frequencies. So just normal CAN bus goes up to 1 megabit per second, and then there is a divider. So like maximum speed, 1 megabit a second. If you divide by 2, you can do 500 kilobits a second. Then you divide that again, you get 250 kilobits a second. Divide that again, you get 125, and so on. And you run out of dividers. So what happens is that if you want to run CAN bus really, really slow, like I think it's 12 and a half kilobits a second, something like that, is right down at the bottom end of CAN bus. On the ESP32, you couldn't specify enough bits, like flags, to divide it down to the lowest speeds. So with the Rev 2 silicon, they added another bit, and somehow it's got screwed up, and it always gets applied. So you end up with half the speed you asked for. Hang on, I got a cough again. Wagon Loads asked, instead of 250 E3, would 250,000 work better? Sadly, no, it doesn't, because the bug still exists in the divider. The flag is being set in the CAN controller built into the ESP32. So, this is the nasty way that I found to get around it. We do if esp.get chip revision is greater than or equal, equal to 2, then we lie. So we'll wrap all of that and that. This is very highly unoptimized code, but anyway. So what we're going to do is handle the situation where we are on the new silicon, and handle the situation where we're on the old silicon. So if you're on the old silicon, you can simply call CAN bus speed like this. So on new silicon, revision 2 or greater, we are going to special case some stuff inside here. Now on the old silicon, we can just use it directly and everything is good. So, time? 5 minutes left.
System notification. 5 minutes remaining.
Okay. So what we do here is Now, this is something that I need to check out. We may be able to simply multiply that value. I don't know if it's an integer or if it's something more complex. This is actually a really good thing to investigate. Prompted by Wagon Loads' question about using 250,000 instead of 250E3, because the 250E3 is defined within the CAN library. Ooh, let's find out. I'm really curious. Okay, give me a terminal, and where is the CAN library? Hang on, I'm just gonna see if I can find it, because if that is, we can simply multiply. Because what I will show you, this is the nasty way that I've done it, and I can say if it is that level of silicon, we can do if can bus speed is equal to 250E3, then we could do, say, uint 32t. I don't even know how big it is, but let's say that bus speed is equal to 500. Let's see if this works, this concept works. And then that we can just say bus speed. So what we're doing is overriding, we could use a switch for multiple things in here. There are only a couple of values you actually care about. And then, I know, this is so super ugly, but this is just to illustrate the logic. If it was 500, then we want to initialize it at 1,000. This is like nasty pseudocode sort of territory. I'm just going to separate it out to show what logical checks I'm doing. So if the CAN bus speed is 250, then what we actually want is flat. Oh, that's going to fail to compile because that's defined twice. Then we make it 500 and initialize it at that. If we're asking for 500, we initialize it at 1,000. The thing is this a simple integer, in which case we can just multiply it and avoid all of that horrible insanity? Let's find out. Where is, oh, hang on, it'll be right here. CAN version, okay, it's in there. All right, that is the location of the library. So I'm going to change into that. And this is a very worthwhile investigation because I have no idea how that value is used within the library. What have we got? Let's do grep minus r 250E3.
Imogen Ann said, I'm putting together my calendar to print out for next year, and came across Squirrel Appreciation Day on the 21st of Jan, which just so happens to fall on a Sunday.
Oh, seriously? That is so cool. Squirrel Appreciation Society is the 21st of January, which is on a Sunday. So for that live stream, it can be the Squirrel Appreciation thingamajigamy. Case long 250. Okay. So it is, let's have a look at that. API bit rate. It is just bit rate in bits per second. I thought that it might encompass things, you know, on serial ports, how you can have number of stop bits and all of that sort of thing. I thought that perhaps it would incorporate some of that as well, but it looks like it is just a simple number, which means we can just do a multiply. And let's, yeah, I think that would work.
System notification.
Stream is over. It'll be over soon. It'll be over really soon. Okay. This is going to be interesting to see. I'm going to get rid of hang on. I'm going to go back to here. All right, we got this. I'm going to get rid of those special case, like those things. I'm going to change that back to that, and I'm going to say ×2. So now, if we're on the recent silicon revision, we are going to take the speed that's been requested and multiply it by 2. Otherwise, we're just going to take it as it is. And in both cases, initialize. So let's just see if it explodes. I'm going to try compiling it. Now, if this thing was seeing the serial device, we could load the code onto it. And yeah, I don't get it. I don't get it. I don't know why the serial interface is not showing up. That's something I'm going to mess around with later. Not on the stream, and figure out why those devices are not coming up on my computer. I might try plugging it into my laptop and see if it works there. Oh, done compiling. Okay, so that is a much nicer solution than what I have done previously. So yeah, that's cool. Hopefully that will work and will give us double whatever this is. Can fail, can initialize. Alright, so now we've got the CAN library installed. We're initializing it. We've got a callback set. Well, actually no, it's not a callback. I've been saying the wrong thing all this time. With MQTT, we have defined a callback in setup. So where is it? I won't bother finding it. Anyway, we defined a callback. What we've got here is just literally a function call, read CAN messages that we are checking every time through the loop. So we are calling read CAN messages, which is grabbing anything that's in the buffer, any packet that is waiting to be parsed, I should say, sticking it in the buffer and outputting some stuff for debugging purposes, and then later we can pass it through to process G-code message. So what we've got here is almost everything that is required to make the conveyor controller work on CAN bus at a basic level. If I added, all I would really have to do is uncomment this and add a line here that takes the CAN payload and squirts it into the G input buffer, and we're kind of done. We're literally one line or two lines away from this being able to receive G-code commands via CAN bus, and that's all it is. So when you look at it like this, like I've done a lot of talking today, but when you look at it, and this, even that's all debugging, that's not even there. This is, at its basic form, all you have to do to receive a packet over CAN bus and end up sticking it into a buffer so that you can then do something with it. Yeah, that's basically it. So we've now almost solved half the problem. The other half of the problem is what to do at this side. This is the OpenKO side, so that when we receive a command like adjust conveyor to a size, we also want to, so we want to do that, like send it to the KO, and also broadcast that on the CAN bus so that the conveyors adjust to that same size. So M21, blah, adjust conveyor to that. Now, what did... I only just realized it's different G-code. See, what I've got here is M21 N93.4 as the code to adjust the conveyor, but the conveyor itself is using G0
System notification.
Y
Peter is
blah.
hungry. 5 minutes ago.
Yep, I'll be going. Yeah, these things make sense in different contexts, because with the pick and place machine, when you're doing a y-axis move, you're not moving the conveyor, you're moving the head of the pick and place machine. So, but when you do a y-axis move on the conveyor, you're moving the back of the conveyor. So they are different things. So what I'm going to have to do is, in the M21 G-code parser, so machine actions, where is M21? So M21, M-code adjust conveyor. Let's see where that is used. Find. And it calls to command adjust conveyor width. So it does that to send the appropriate signal to the machine. So that's in machine actions. Come on, where is it? There. Adjust conveyor width. So what I'm going to need to do is, where was it? Where was the caller? Here we go. So this is, we've received the command to adjust the conveyor width. So we call that to do the conveyor adjustment on the KO. And then we're also going to need to do something like can send conveyor width, requested width. Now that function obviously doesn't exist yet, but we're going to need to do something like that to to send the message via can, and it's also going to have to be in a different format. So I'm just going to comment that out for now. And what I'll do is, in the can thingamajigamy, send conveyor width to can. I've already got this function. Send conveyor width to can. Width, float width requested. Okay, let's at least make this send conveyor width to can. Yeah, that'll do. Okay, so we've got this function that currently does nothing. Oh, so it exists. All right, so which means I could even uncomment that now. We're going to be calling this anytime we send a conveyor adjustment to the KO. We are then also going to send conveyor width to can, which invokes this, and it just outputs it and does nothing. So the next thing to do is, in here, we need to send a can message with the appropriate G-code in it so that it can be received here and then passed on to the G-code processor. So you can see we're not really that far off. It's been a lot of talking for a very small number of lines of code written, but we're kind of close to being able to test this. It won't take a whole lot to add a function in here to send a message with the appropriately formatted G-code. And also I need to fix the, where is it? In here, do I have the can begin? Did I even do this? No. So I don't have any can initialization stuff in here. So I need to copy over from in here. In fact, before I wrap up the stream, let's add this in here so that we've got both of these. Come on, where is it? Resources, libraries. Where have I? Oh, I don't have any libraries. Okay, so I'll include the can library, and then in config, let's do this. Can bus speed can. Let's add this config in here. Config can bus speed. Okay, I've already partly configured that. So we'll do that. And those pins may need to change. I don't know. I've got to actually look that up. Haven't run any of this on the real hardware yet. Then in setup, we want to initialize CAN bus, and we'll just do it in the same way. So Where does that one end? There. Set up the can. In here. Where's setup? Setup, setup. Enable KO, blah, input buffer reserve. Yep, let's stick it down there. Alright, so we've initialized the can thing. Also, I need to make an option to disable can entirely because people might want to run OpenKO without can. Then, what else have we got? So we've got the can comms thing. There is that most of which is going to be deleted. And that. Send conveyor width to can. Yeah, okay. We're close to done. Probably doesn't really look like it, but that is really, really close to done. In here it just needs to format the can message and send it. So, time to take a breath and look at the chat. Oh, Tradie Trev says, does OS 10 have an LSUSB command? It's got something similar. I can't remember if it's exactly LSUSB. No, that's like an internal function. But LSUSB, yeah. It's an internal function in a library or something. Yeah, anyway, I will debug that whole USB thing and why the thing isn't appearing as a serial port. I'll fix that and then we can try it. Hang on. What? Simon... wow, sorry, I've just been thrown for a loop because in the chat, a message from Simon is, hello, I'm Simon Rand's wife, and I'm writing to say that Simon lost his battle with cancer on 12th November this year. What? Wow. Oh, that... I had no idea. Well, I don't know what to say. I'm really sorry to hear about that. That came out of the blue. Well, I'm glad that he did enjoy being part of this community, and yeah, it was cool having Simon in the chat. So I'm really sorry to hear that you're going through that. That's really tough, and I hope you're doing okay. Yeah, I don't know what else we can offer to help in that situation. Yeah. I'm so sorry. I know it was, if it was on November 12th, then you would have gone through all sorts of different emotional stages since then. And, yeah. So I've got no idea what state you're in right now, but I hope you're doing okay, and that you've got plenty of people around you that that you can talk to and help you through this, and or to give you the space that you need at the times that you need it, because going through the grieving process, sometimes you need space, sometimes you want people there. So, well, I just hope you're okay, and if you do want to come back in the chat at any point and talk about things, or if you want to talk about things on Discord, then obviously you're very welcome there as well. So, yeah. thank you for jumping in and letting us know as well. I really appreciate that, because in this sort of situation, it could be very easy for Simon to have just never appeared in the chat again, and we would have had no idea that this had happened. And I appreciate you jumping in the chat and letting us know about this. Yeah. Well, it is time to end the stream, but I'm really sorry that you're going through this. Yeah. Oh, so so that message was, thank you all so much. Sorry I didn't know how to contact you earlier. Kind regards from Delane Wren. Well, if you ever do want to come along to one of the barbecues and have a chat to people, obviously you're extremely welcome. Second Sunday of the month here at the Super Lab in Melbourne. There are always a bunch of nerds around chatting about both nerdy techie things and more personal things that are going on in their lives. So if you do feel like coming along and talking to a couple of other nerds, you're always welcome to do that. The details are in Discord, and yeah, as I said before, if you want to just chat in Discord or whatever, please feel free to jump in there. I should put that link in for general purposes anyway. Superhouse/Discord. I'm going to put the link in the chat, and I know that so going through Christmas and all of these sorts of family events and things, having just lost someone, would be really rough as well. So please reach out if you need to. Okay. So that does lead into something that I was going to mention today anyway at wrap-up time, which is, and this is a bit of an extreme example, but I know that for many people Christmas is a rough time of year as well, like the holiday break and family events. There are many reasons that it can be tough, either because you are on your own and lonely, or you might be going to family events where there is family conflict and issues within family and friendship groups. So even though it is generally a very happy, positive time of year, it can also be really challenging, and there are many reasons for that. So if any of you are having a difficult time, please feel free to reach out, and you can DM me through Discord, or just jump in Discord and talk with fellow nerds. And yeah, there are a few of us around. We'll be there for you. So yes, so Sion's message was, Merry Christmas and Happy New Year to everyone. Hope you all have a fun time and stay safe. COVID is still a thing, so please be careful. Yep. So, and Chip said, I struggle to like Christmas as I've been jobless and homeless for many of the most recent years of the festive season. Yeah. So there are many reasons that this can be a hard time of year. There are many positives, there are many negatives. As with all things, it's just that this particular time of year accentuates and highlights those things and brings out both the positive and the negative emotions. So my thoughts go out to all of you. I hope you all do have a really nice Christmas break, and I am going to see you, let's see, it is Sunday 24th of December right now. The next Sunday is New Year's Eve, so there is one more live stream before 2024. So I will see you once more in 2023. And I hope you all have a really nice day tomorrow for Christmas, or the Saturnalia, or Festivus, or the summer solstice, or whatever it happens to be. Wagon Load says, don't forget the reason for Christmas. Yes. So celebrate in whatever way is meaningful to you, and I hope you all have a great time. Yeah. So thank you very much for hanging around with me during this year and being my super friends that keep me sane on a Sunday morning. It is so good to be able to chat to so many people every week and have this sort of interaction and talk about things that are both technical and personal. So, Merry Christmas to everybody, and I will talk to you all next Sunday morning. So I will see you then. In the meantime, Merry Christmas, and go and build something awesome. See ya.